Here's a similar one. We're given that the measure of, or the segment MK is congruent to segment OK. All right, so I'll just start writing this in. All right, so MK is congruent to OK. And we're given that KJ, segment KJ, bisects angle MKO. All right, and those givens. All right, and so if we have a bisector, what does that tell us? That tells us that we have congruent, that the segment splits an angle up into two congruent angles, right? So if KJ bisects MKO, right, that must mean that angle 3 is congruent to angle 4. Okay, so I can say angle 3 is congruent to angle 4, and I can say definition of angle bisector. All right. Okay, so I'm going to put that in here. So now I have a side and an angle, right? So I could use angle side angle, angle side is a possibility, or we could do side angle side, right? If we're looking at the diagram here, we have a shared side, so that's easy reflexive property, right? Easy reflexive property there. So JK is congruent to JK, or I'll just put KJ just to switch it up a little bit. Same thing. And the reason why is because of the reflexive property. All right. So now we have side angle side, right? So we can say that these two triangles are congruent. Triangle JMK is congruent with triangle JOK. And this is a postulate. All right, and then now that we have that, we can say, okay, if we want to know that that JK bisects MJO, right? So we want to know JK bisects MJO, that means we need to know angle 1 is congruent with angle 2, right? And we do know that now because those are corresponding angles, right? Angle J corresponds with angle J, so I can say that angle MJK is congruent to angle OJK, and that's by CPCTC. All right, and now that we prove that those are congruent, now that means that KJ must be the bisector, right? So KJ or JK bisects angle MJO, and that's because definition of an angle bisector. All right, here's another proof. So given that two pairs of sides are congruent, and we're trying to find that a segment bisects an angle, right? So if we can find the two angles are congruent, then we can know that LO is a bisector. So we probably want to find the triangles are congruent, then we can use CPCTC to find the angles are congruent. Then we can go to bisector. So segment LM is congruent to segment LN. That's given. So these are congruent. And also segment KM is congruent to segment KN. KM is congruent to KN. All right, so notice that we have a few different triangles going on here. We have, actually 6 that I can see, or 7 actually. And so, but this is the one that seems to be the best one to work with, right? Because we have 2 parts of each of those triangles. We have a third part that we can find by the reflexive property, and we want LO to bisect MLN, right? So that's this angle here, which is which we can use each of those triangles for, right? So let's use the reflexive property next to say that what is that? LK, right, is congruent to itself. So LK is congruent to KL or LK, and that's by the reflexive property. Okay, and now that we say that, we have side, 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 right? And so we can say that triangle LMK is congruent to triangle LNK. All right, now that those two triangles are congruent, we can say that these angles must be congruent, right? Because those are corresponding parts. So angle MLK is congruent with angle NLK. And the reason is CPCTC. Now that we see those two angles are congruent, we can say that LO, segment LO, bisects angle MLN, right? So this bisects this, right? And forms two congruent angles there. All right, and the reason why is definition of angle bisector.